One of the most amazing things about nature, by which I mean the universe, the world, human beings, all of it, the whole shebang, is how nature often preserves and contains elements of its own history. Here is the famous picture of the cosmic microwave background, a remnant of a very early stage of the universe. It's the oldest electromagnetic radiation extant in the universe, uniform in every direction, and supports the Big Bang model of the beginning of the universe. Not to delve more deeply into the topic, but here we have the oldest and earliest example of the universe containing and preserving elements of its own history. And this picture of moon footprints. If you weren't sure whether we'd gone to the moon, this preservation of that historic visit would probably convince you, unless you're an Apollo skeptic. Compared to the cosmic microwave background, this is a concrete example. You just look at it, there's hardly any work or analysis to do. But not far away, there are craters. And these too contain information about their history. A history of bombardment long, long ago. But it would take a lot more work to uncover their story. If we dug into them the way scientists do with the much more rare impact craters on Earth, and were able to study the age of the surrounding rocks and remaining data about the composition of the impactor, we would find that there is quite a bit of information about the moon and its history hidden in that crater. And rocks are especially good at retaining history. Along those lines, I recently made this video about the amazing new discovery in North Dakota that illustrated the mind-boggling likelihood that fossilized rock recorded the very moment the dinosaurs were exterminated by the Chicxulub asteroid impact. I don't know about you, but my mind is still ringing like a bell over that revelation. That's preservation of history beyond all expectation. What amazes me is how much of history isn't gone completely. Often useful information remains. And it's fascinating to see all the ingenious ways we come up with to unlock this information. One indicator of my fascination with this property is the fact that I've already made several videos about it. This video, When Did Humans First Wear Clothes?, shows that surprisingly, we can use the genetics of lice to figure out that we started to wear clothes 170,000 years ago. Lice that live on clothing only came into being once we started to wear clothing, evolving from head lice and beginning to diverge from their head lice brothers and sisters. This introduced the concept of a molecular clock, a way of measuring time through genetic differences. When two life forms diverge, some of their important molecules, especially proteins and DNA, mutate randomly over time in an approximately steady way. And thus these molecules in the two life forms become gradually more and more different, and the amount of that difference is a good estimate of the time since they diverged from each other. In this case, scientists looked at the differences in the DNA of head lice and clothing lice, and from that we can tell when humans began to wear clothes. So in a remarkable and unexpected way, the genetics of lice have preserved the information of when human beings began to wear clothing. And this video, Ancient Roman History Preserved in Ice Cores, shows how lead pollution from the period of the Roman Empire, a byproduct of various industrial processes, went up into the atmosphere and some of it fell onto the pristine Greenland ice. This pollution can now be analyzed, quantified, and dated. And the amount of lead pollution tells us about the economic and industrial activity taking place at various times during the history of ancient Rome. So lead pollution is being used as a proxy for economic activity, and this history has been preserved in ice and now is visible to us once again. Almost 2,000 years later, we see that some of the information about the history of the Roman Empire wasn't actually lost to us after all. Human evolution and paleoanthropology use interdisciplinary approaches to unlock preserved history. These numerous videos reveal history preserved in fossils, in genetics, in artifacts, and these are only some of the tools that scientists are finding to unlock the preserved history of our evolution. To shift entirely, this video, Finally We See the Objects That Formed the Solar System, showed how the tiny planetesimals, rocky remnants orbiting beyond Neptune, exist as time capsules from the formation of the solar system 4.6 billion years ago. The materials that came together to form the Earth are not entirely lost, but rather are now seen again as humans have traveled beyond the furthest planet in the solar system to examine them. History in deep time, still preserved. So we've talked about numerous ways that information in time is preserved. In the radiation in space, in the fossilization of rocks, in genetics, in physical artifacts, in so many ways. Let me just mention two more. How about languages? Relationships between languages contain a lot of history about those languages. Languages contain words and histories that still show their ties to one another, and often illustrate their connections to languages that came earlier. Two languages are considered to be genetically related if one is descended from another, or if both are descended from a common ancestral language. This diagram shows the genealogy and history of the relationships among languages descended from Latin. Italian is descended from Latin, and the living language of Italian preserves the history of its relation with Latin and with earlier Indo-European languages. Italian and Latin are therefore said to be genetically related. Spanish is also descended from Latin. So Spanish and Italian are genetically related too, although the nature of the relationship is different. And Spanish and Italian both preserve their history of descent from Latin. Looked at this way, Spanish and Italian contain their histories, and this diagram of language relationships and histories of descent from Latin doesn't look radically different from this diagram of branching in the deep past, billions of years ago now, that shows the relations of the three basic divisions of life: bacteria, archaea, and eukaryotes. Or this one that illustrates the history of relations among the superfamily Hominoidea, of which humans are a very important member, along with chimpanzees, gorillas, and many extinct species related to us, and part of the preserved history of our ancestry. And finally, humans contain their own history. If you remember something of your childhood, or what you did yesterday, this seems an obvious point. Of course, we don't remember everything, and certainly not consciously, but our minds and our bodies, look at your scars for example, do preserve much of our history. As the poet William Wordsworth famously said, "The child is the father of the man." So often history isn't completely gone. Pieces, remnants, and evidence of it are sometimes still present, and often in unexpected ways and places. I find this fascinating and profound. Is there a why to all this? Is there a meaning to the preservation of history? I think we are not speaking of one phenomenon. Many things are preserved, and many things upon examination reveal evidence of how they were originally formed. Common tables and chairs do this too. Solids retain their shape and are therefore better than liquids and gases at retaining pieces of their history. Even so, the cosmic microwave background we discussed earlier isn't in a state of matter per se, but instead is really a form of energy. Genetics and fossilized life forms reveal a history of evolutionary relationships. Language preserves evolutionary relationships too, but in this case it's cultural evolution that's preserved. And spoken languages preserve the past in an abstract form. The rocks that formed the solar system are unchanged for 4.6 billion years. But what's striking is that while these are old and plentiful, they are located beyond Neptune, not here on Earth. And I think that's the point. What these all have in common is not one unified process, but rather the element of surprise to the human observer, the sense of astonishment and fascination that something so old or unexpected or hidden is actually accessible and present. Perhaps it is this feeling that unites these disparate phenomena. So the next time I present some information that I'm excited about, it will not be only because I want to communicate that information. It will also be because I'm hoping that you will have that exhilarated feeling of awe and wonder that I find is among the greatest feelings in life. Be sure to subscribe, hit the notification button, and thanks a lot for watching.